Welcome back. So now we are looking at problems from section 3.5 from our workbook, web work rather. So the first question refers to a polynomial fx equals 3x to the power 5 minus 7x to the power 4, and there are quite a few questions. But notice these questions do not address all the issues that graphing of a function without using graphic calculator would do. Okay, so what I'm saying is this particular section 3.5 talked about sketching a graph, okay, summary of curve sketching, and it had guidelines starting with domain, then intercepts, symmetry, let's see, asymptotes, intervals of increase decrease, local max and min values, concavity, finally sketching of the curve. So I would like to show you all these various steps for our question here, problem 1. All right, it is useful exercise for us to know to implement all of these to be able to draw by hand any curve. So I'm going to go through these in various videos because this is a very long problem. Okay, so this is the first video for problem 1, web work 3.5. My question is it's a polynomial function. Fx equals 3x to the power 5 minus 7x to the power 4. The very first item in our checklist is the domain. Well, we are a polynomial, so its domain is set of all real numbers, which is negative infinity to infinity, the open interval. Notice a polynomial does not have denominators, does not have square roots, so there are really no issues. So this function is defined everywhere, okay, all of real line. The next item in our checklist is the set of intercepts. To find the y-intercept, you would set x coordinate equals 0. So I'll put x coordinate equals 0 to give me y equals 3 0 to the power 5 minus 7 0 to the power 4, which is a 0. So the y-intercept is 0 x coordinate and y coordinate 0. All right. To find x-intercepts, you would set y equals 0. Y coordinate is this function. Y equals 0 means your expression is 0. Factor this. That's how we always solve for x. Factor if we can. X to the power 4 is common. What's left is 3x minus 7. All of this is 0. Which tells me x to the power 4 is 0, or the other factor 3x minus 7 is 0. This gives me x equals 0, and this I'm trying to solve for x. Move the negative 7 to the other side and divide by 3. Okay, so you get two x-intercepts. One is with x equals 0, which we had already calculated. Mind you, 0, 0 is both an x-intercept as well as y-intercept. Okay, so, and the second one is with 2 and 1/3, which also gives me y equals 0. That's how we solved for it. Okay. The third item in our checklist is symmetry. Symmetry, we can have symmetry if you have an even function, or if you have an odd function, or if you have a periodic function. So there are three things to check. Is your function an even function? How do I know what is the test for even function? Well, whether f of negative x is equal to f of x. Well, plug in negative x. Negative x to the power 5, the negative survives because an odd power, negative survives. On the other hand, negative to the even power, the negative does not survive. Okay, this negative is from negative 7. Okay, so that continues, but this negative goes away. So in all, you have negative 3x to the power 5 minus 7x to the power 4, which is not equal to fx, which was 3x to the power 5 minus 7x to the power 4, because these two do not agree. In other words, f is not an even function. If it is not an even function, there is no symmetry about the y-axis. Even functions have a left-right symmetry. So as my function is not even, the left-right symmetry does not happen. Next question. Is f an odd function? In other words, you want to check whether f of negative x is same as negative of fx. Well, figure out f of negative x. I'll plug in negative x in place of x, but we did that calculation right over here. We got negative 3x to the power 5 minus 7x to the power 4. All right. Now, what about negative of fx? Well, look, it looks very close, but what is negative of fx? Go back to fx. If I take the negative of this entire thing, I have to change the sign here as well as here. In other words, I get negative 3x to the power 5 plus 7x to the power 4. That's why they do not agree here. Okay. So it is not an odd function. If it's not an odd function, there is no symmetry about the origin. If you remember what is the symmetry about origin, that happens for an odd function. You have to, if you could rotate it 180 degrees, you'll get the same picture back. And that is the meaning of symmetry about origin. But that does not happen here because my function is not an odd function. The next part is of symmetry is whether f is a periodic function. Well, no. Typically, functions involving trigonometric functions or functions which are specifically defined periodically are periodic functions. Functions defined periodically are defined piecewise, basically, you see. But our function is a polynomial function. Polynomials, rational functions, or radical functions are not periodic. The next item in our checklist is the set of asymptotes. Do you have horizontal asymptote? Do you have vertical asymptotes? And do you have slant asymptotes? There are three aspects to asymptotes. How do you encounter horizontal asymptotes? Well, you have to check limit x approaching infinity or limit x approaching negative infinity. You see whether these limits give you a number. Okay, so let's look at limit x approaching infinity of fx. Limit x approaching infinity of 3x to the power 5 minus 7x to the power 4. Get the highest power out. We are looking for infinite limits, okay? Get the highest power out. So what survives inside is 3 minus 7 over x. You see, when I get higher power out, I get a denominator. Now when I let limit x approach infinity, this x to the power 5 goes to positive infinity. 3 is unaffected. 7 over x goes to 0 because x is approaching infinity. So in other words, I'm going to get 3 times infinity, which is an infinity. It is not a number. So this does not give me a horizontal asymptote. So why don't I try with a negative limit? So limit x approaching negative infinity of fx is, well, write down the expression again. The same story, get the high power out. Okay, when I take x approaching negative infinity, this one, the negative survives, so I get a negative infinity. All right, this goes to 0 and I only have 3 here. So 3 times negative infinity is a negative infinity, well, which is still not a real number, so I do not get any horizontal asymptotes. What about vertical asymptotes? When do you get vertical elements, asymptotes? When the limit at a number goes to infinity or goes to negative infinity. Why would limit at a number go to infinity or negative infinity? Well, if it were in the denominator, but I am a polynomial. It has domain all real numbers. So there is no real number a such that limit x approaching a from the right or limit x approaching a from the left is going to be an infinity or a negative infinity. That is, there are no vertical asymptotes. Okay, polynomials will not give you vertical asymptotes. Slant asymptotes. Now, as f is a polynomial function, it does not have a slant asymptote. In our class, we will encounter slant asymptotes in the cases of rational functions, where degree of the numerator is one more than degree of the denominator. It's in our class of calculus 1, this is the only place we'll see slant asymptotes. Okay, but we are a polynomial, so we don't have slant asymptotes. All right, I will stop this video here and continue with the next items in our checklist. So until then.